Hello and welcome to solving quadratic equations by factoring. We want to use the zero factor property. That means if the product of two numbers is zero, then at least one of the two numbers is zero. So if we can take some examples, starting with this one, solve the following equations by factoring. So what you want to do is look at x squared minus 49 equals 0 and realize that this can be broken into two separate sets of parentheses equaling 0. And inside each of those sets of parentheses you're going to have an x doing an operation to a number. So this 49 is a perfect square, so we know we're going to have x doing something to 7 and then x doing something else to 7 equaling 0. So with how this would factor out is that we'd have x plus 7 for one term and x minus 7 for one term, because if we were to FOIL this out, we would be left with the x squared, and the middle terms would cancel out due to the plus and minus terms, and the 7 times 7 would yield the 49. So if we actually take what we have now factored out, the x plus 7 and x minus 7 equaling 0, we can break the terms apart into x plus 7 equals 0 and x minus 7 equals 0. For this first one, we want to solve for x, and to do that we have to subtract 7 on both sides. When we do that, we have x equals 0 minus 7, or just minus 7. For this other piece, we have x minus 7 equals 0, so to free x, we add 7 to both sides of the equation. We have x equals 0 plus 7, or just x equals 7. Okay, for the second example, we have x squared plus x equals 4. So what we want to do is always make sure that one side is 0. So to do that, we have to first subtract 4 on both sides of the equation. If you see, we bring down the x squared plus x, and we bring down the minus 4, since there are no common terms. And then on the right side we have 4 minus 4, or just 0. Now we're able to factor, so we'll break into our two separate pieces of parentheses equaling 0. So this x squared with the coefficient of 1 tells us to put an x at the beginning of each set of parentheses. Okay, now we look at the signs. The sign of C here, where this 4 is a negative, so that means we're going to have a positive and a negative operation. Now we have to think of the factors of 4, the multiples of 4, that when you combine them through adding and subtracting give you the coefficient of b, which in this case is 1. So what are the factors of 4 that when you add them give you 1? If you think about it, there is actually a goof up in this problem. There should be a 3 coefficient in front of the x instead of a 1. So now that changes the problem a bit to think about what will multiply to give you 4 that when you add or subtract them give you a 3. That would be 4 and 1, and one of them has to be positive and has to be negative. The sign of b is positive, so that means the larger has to be positive. So it's going to be a positive 4 and a negative 1. To break these pieces apart, we have x plus 4 equals 0, and x minus 1 equals 0. Alright, on this first piece, this x plus 4 equals 0, to get x by itself, subtract 4 on both sides of the equation. It's going to leave you with x equals 0 minus 4, or just x is equal to negative 4. On this other piece, we have x minus 1 equals 0. To get x by itself, add 1 to both sides of the equation. You have x equals 0 plus 1, or x is just equal to 1. Okay, with number 3, first what you can see is that we have two sets of perfect squares. The problem is 121x squared minus 144 equals 0. If you see, 121 is the multiplied parts of 11 squared, and 144 can be broken into 12 squared. So we can break into our pieces of 11x for the first part, doing something to 12, and for the second set of parentheses, 11x, doing something to 12, closing parentheses, and then setting the whole thing equal to 0. So we have to think, what can we do for our operations here that will cancel out any middle terms and just leave us with the first two pieces of the problem? If we were to put a plus and a negative in, that would cancel out any middle terms, just leaving you with the x squared term and the number with no variable attached to it. So now we can set these two terms equal to 0. So we have 11x plus 12 equals 0. We have 11x minus 12 equals 0. For this first one, we want to get x by itself, so we subtract 12 on both sides of the problem, leaving us with 11x equals negative 12. To get x by itself, divide by 11 on both sides, because the 11 is multiplying by the 12, and we have to do the inverse operation to get it by itself. So we're left with x equals negative 12 over 11. And for this other part of the problem, we have 11x minus 12 equals 0. To start getting stuff away from 12, we have to do the opposite of this negative that we see beside the 12. So we have to add 12 to both sides of the problem. So we have 11x equals a positive 12, because 0 plus 12 gives us 12. Now to get 11 away from x, we have to do the opposite of what's happening. It's being multiplied, so I do the opposite operation, which is division. So divide both sides by 11, leaving you with x equals 12 over 11. And for our last example, in this case, we have the problem x squared minus 2x minus 15 equals 0. So we can go ahead and start factoring. We set the x squared has a coefficient of 1, telling us to go ahead and open up two sets of parentheses equaling 0. The first part of each set of parentheses should have an x in, because that would give us our x squared term. Okay, now we have to think of our signs. The sign of c is negative, so that tells us we're going to have a positive or a plus and a minus happening inside those parentheses. Now we have to think of things that multiply to give us 15, that when we combine them through adding or subtracting gives us 2. 15 and 3 would give us 15, and if we were to add 5 and 3, that would give us 2. And the sign of b is negative, so we have negative 2. So that means the greater of the two would have to be negative. So if we had a negative 5 plus 3, that would give us a negative 2. And if we had a negative 5 times 3, that would give us a negative 15. That meets the qualifications that we need. So let's put a 5 in where the negative is. Let's put a 3 in for where the positive is. And let's take our two pieces, set them equal to 0, and solve for x in each case. So for this first part, x plus 3 equals 0. To get x by itself, we have to do the opposite of what's happening, which is a positive 3. So we have to subtract 3 on both sides to get it away. So we have x equals 0 minus 3, or just x is equal to negative 3. Over here on the other problem, we have x minus 5 equals 0. Well, we see this is a minus happening to the 5, so we have to do the opposite to get it away. So we have to add 5 to both sides of the problem. So we have x equals 0 plus 5, or that x is just equal to 5.